Good evening, sir.
Good evening.
Good evening, sir.
Good evening, sir.
Hello. Okay, now am I audible?
Yes, sir.
Yes, sir.
Okay, just 1 minute. Fine. Still am I audible?
Yes, sir.
Okay, let's
Yes, sir.
continue. So still, I was facing some mic issues in my laptop. So somehow I've sorted it out with some other way. Let's continue it. So today we'll continue with revision of chemistry, acids, bases, and salts, right? And all of you be active while this be active during the class. So we had done something related with acids, bases, and salts. We had seen how to measure their strength, and we had seen organic acids or the division of acids on different bases. So we had seen here organic and inorganic acids. Organic and inorganic acids. We have seen weak and strong acids. Weak and strong acids. We have seen dilute and concentrated acids. Acids. Now we were doing the testing for the acids or test for acids. So the different tests that we have for acids and bases, we have litmus test. Then we have turmeric test, which is for bases. It's for bases. We have olfactory indicators. So in the olfactory indicators, we have seen onion as an olfactory indicator. Vanilla as an olfactory indicator can be used. The next thing we had to do some important chemicals from common salt. So what are the important chemicals from common salt? Yes, how do we obtain those chemicals from common salt? Yes, how do we obtain those chemicals from common salt?
Chloralkali process.
By the chloralkali process. Okay. So we have done the chloralkali process here. So just in short, we will do. In short, we'll understand chloralkali process. What is the name of the solution that we take? Yes, what is the name of the solution that we take here?
Brine solution, sir.
Brine solution, right? So here we take up a brine solution. Brine is a concentrated solution of HCl in it's a solution of water in salt in water. Here brine. Then we make two electrodes here. Okay, all of you write down three things till I'm making this. You write down these three things. You write down the first you'll write down reactions occurring in the solution that you'll write down. Then you will write reaction at positive electrode and then reaction at negative electrode. At the last, you write a reaction at negative electrode. Write down these reactions. Yes, 1 minute again. Yes, am I audible to you all?
Yes, sir.
Yes, sir.
Okay, okay. So write down the reactions. Quickly write down the Have you written down the reactions?
Yes, sir.
No, sir. Wait, sir.
Okay, now see, finally I write down the reaction. Just have a check on the reaction, whatever reaction you have written, whether it is correct or not. So just check the reaction. If you can show it, I will check it instantaneously. So all those who have done it, they can just show the reaction. Okay, is there anyone who has done?
Sir.
Yeah, Moksha, just show it. I think it's Moksha. So just 1 minute. In the solution, you have NaCl, positive, negative. No, not in this way. I want the answer something like this. Okay, see. Okay, Moksha, thank you for trying out. Let's see how I expect the answers. So we will be writing the reaction in the solution. So in the solution, you have, so I put here in solution. I get NaCl being converted, giving ions as Na plus and Cl minus. Then we have water splitting up to give H plus ion and hydroxide ions. So the hydroxide ions, they have something like this. If you have 4 molecules of hydroxide ions, they combine to give 2 molecules of H2O and 2 molecules of oxide ion. So this is the reaction which is occurring inside the solution. At the positive anode, what happens? At positive electrode, we will be getting the negative ion, like the chloride ion moving towards it. So you will have Cl minus ion plus the Cl minus ion. It moves to the positive electron. So it transfers the electron that it has. So it becomes chlorine and gives out 1 electron. So this is the reaction occurring at the positive electron. Then the chlorine atom combines with another chlorine atom to form Cl2 gas. So at the positive electron, whichever electrode is connected to the positive terminal of the battery over there. So here this electrode is connected. So here I will have the evolution or formation of chlorine gas here. So here I will get chlorine gas, CH2. Here in this first one, I will be getting hydrogen gas. How we will like get? So again, write the reaction at negative electrode. At the negative electrode, the sodium ion, H plus ion moves, not the sodium ion. Why the sodium ion doesn't move? The reason being of its electropositivity. The electropositivity of sodium ion is much more as compared with the hydrogen ion. So therefore, it is the hydrogen ion which gets reduced first and not the Na plus. Okay. So your H plus ion, it starts moving towards the negative electron, and that since the negative electrode is rich in electrons, so the H plus ion, it accepts electrons from hydrogen, and you get hydrogen plus 1 electron. H, because H plus, it accepts 1 electron to form hydrogen atom. 2 hydrogen atoms combine together to form hydrogen gas, H2. So at this negative terminal, you obtain hydrogen gas. At the positive terminal, you obtain chlorine gas. And inside the solution, you have Na plus and OH minus remaining. So this Na plus and OH minus together form NaOH. So in the same, I'll write here Na plus OH minus, which means NaOH. Got it now? So looking at this reaction here. In the solution, I'm getting Na plus OH minus. So this gives me caustic soda, NaOH here. So these are the different products which are involved or products which are formed. You get chlorine gas, you get hydrogen gas, and you get caustic soda, sodium hydroxide. Now we'll observe the acidic and basic nature in our surroundings, where all we observe acidic and basic nature in our surroundings. So with the tooth decay, let's see what happens with the tooth decay. Yeah, Sumu, can you explain the tooth decay? Sumu,
Sir,
can you explain tooth
the
decay?
tooth enamel is neutral, and when there's too much acidic concentration in our mouth, toothpaste are used to neutralize it, as toothpaste are basic.
Okay, so what does it form finally? Yes, how do you find it? You have your acid, whatever food you eat. So that food gets stuck to the tooth and it gets converted to acid by the bacteria. So you have the formation of acid in your mouth. That acid reacts with your tooth enamel. So since yeah, it corrode the surface. So you have the surface as corroded. And after the corrosion, more and more cavity is created. So in the cavity, there will be formation of more of the cavities, which will lead to the deposition of more amount of food. Got it?
Yes, sir.
So I think now we are left only with the salts from this chapter, right? We'll see the assignment which I had sent you. Did I send you any of the assignment in the group earlier from this chapter?
No, sir.
I think we were practicing a worksheet from this. Okay, maybe it's not there. Just let me get it again and practice it. We have acids. Hmm. Okay, so there were two of the PDF which I think I had sent you. Just one. Let me share it right now. One minute, one minute. It's there in the group now. You can just start over there. So we are going to solve those questions which are given. Chapter 2. Fine. So just see the first question. And all of you now become active for solving these questions. Name the natural source of each of the following acid. Natural source of citric acid,
Lemon, oranges.
Lemon.
lemon and
Lemon, sir.
oranges. Okay. Natural source of oxalic acid,
Tomatoes.
Oxalic. Tomato.
yeah, it is tomato. Everyone become active. Everyone, I want answers from everyone. If I don't receive any answer from someone, so I'll just inform. Then lactic acid,
Milk.
milk
Milk.
or curd.
Curd.
We don't curd.
Curd.
Tartaric acid,
Tamarind.
Tamarind.
tamarind. Okay. A student detected the pH of 4 unknown solutions, A, B, C, and D as follows. Predict the nature of the solutions.
First one is basic. Highly
The first-
basic.
Basics. Second one
But
is
Second one's
weak
acidic.
acidic, weak acidic.
acid, okay, weakly acidic. And third one,
Seventh
C,
is seventh is
Neutral.
neutral.
neutral. And 2,
2 is
Highly
strong
acidic.
acid.
yeah, it's strongly acidic. Then give the constituents of baking powder.
Baking soda and
Baking soda and,
tartaric acid.
yeah, a baking soda and a mild acid like tartaric acid can be used. Why cake or bread swells on adding powder?
Due to CO2 bubbles.
Write the reaction. All of you write down the reaction involved. Okay, so for all the chapters of science, I'm just adding a PDF of Kendri Vidyalaya, which you can access it from your assignment section, right? Okay, what's the answer? Have you written down the reaction?
Yes.
Okay. So, see, your reaction should be something like this. For this one, wine, cake or bread swells up on adding baking powder. For this one, we are writing the reaction. So your reaction is you have sodium hydrogen carbonate, NaHCO3, when heated up. So it gives us Na2CO3, sodium carbonate, plus carbon dioxide, plus H2O. Can you write 2? Now the reaction is complete. Everyone has written the same reaction?
Yes.
Next is a white colored powder is used by doctors for supporting fractured bones. Write the chemical name and formula of powder.
Plaster of Paris.
Calcium hemisulfate.
Calcium sulfate hemihydrate.
Hemisulfate.
Calcium sulfate hemihydrate. So you have to write both things, chemical name and chemical formula. When you say plaster of Paris, it's not the chemical name, it's the common name. So be careful while writing the answers. Its chemical name is calcium sulfate hemihydrate and chemical formula is CaSO4 dot half H2O. Then when this white powder is mixed with water, a hard solid mass is obtained. Write the balanced chemical equation for the change. So for this one, you will obtain the CaSO4 dot half H2O, but plus you add 3 by
Plus
2
one by
yeah, that's 3 by 2 molecules of water. So you get CaSO4 dot 2H2.
two.
Explain the action of dilute hydrochloric acid on the following with chemical equation.
Magnesium chloride and hydrogen gases evolved in the first one.
So in the first one, you will have the formation of magnesium chloride, MgCl2 plus hydrogen gas. For the second one, sodium hydroxide,
Salt NaCl plus H2O.
okay. Here you get the product as NaCl plus H2O. Then crushed eggshells,
Calcium chloride plus H2 plus CO2. H2O plus CO2.
okay. You have crushed eggshells, they contain calcium carbonate. So you get calcium carbonate plus HCl, giving rise to the formation of calcium chloride plus CO2 plus H2O. Okay, so here you have the formation of H2O and not hydrogen. Okay, now see, dry pellets of a base X, when kept in open, absorbs moisture and turns sticky. The compound is also formed by chloralkali process. Write a chemical name and formula of X. So which compound are they talking of? Yes, any guesses for the compound? Okay, see, just recall the products obtained by the chloralkali process. What were the products obtained during the chloralkali process? Yeah, Sumuk, what were the products obtained by the chloralkali process? Sumuk?
Yeah, sir.
Yeah, what were the
Sir,
products of
sir, chlorine,
Hmm.
hydrogen,
Yes.
and sodium hydroxide.
Okay. Now, out of the three, which one is obtained in the solid state?
Sodium hydroxide.
Okay. So, what will be the answer to this question? Guess the answer to this question.
Yes, sir.
What's the answer?
Sir, sodium hydroxide.
Yeah, it's sodium hydroxide. Dry pellets means dry solids of or dry crystals. So they are sodium hydroxide. So chemical name is sodium hydroxide. Formula of X, that's NaOH. Describe the chloralkali process with balanced chemical equation. So we did it just now. Name the type of reaction occurs when X is treated with dilute hydrochloric acid. So what is the type of reaction? Moksha, what is the type? Yeah, it's neutralization reaction. Very good. So it is the neutralization reaction. Write chemical equation while diluting an acid. So while diluting an acid, sorry. Write the chemical equation we have already done. While diluting an acid, why is it recommended that the acid should be added to water and not water to acid? Why it
Water
is
to acid
recommended?
would be highly exothermic reaction and would
Yeah,
explode.
it will be highly exothermic. A lot of it will be generated, which for which there is no place for absorption, and hence it will lead to bursting of the vessel. Then see question number 2. Think of this, everyone. Crystals of a substance change their color on heating in a closed test tube. but regained it after some time when they were allowed to cool down. Name the substance and write its formula. So which is the substance? Yes. Did you get anyone? Which crystal are they talking of? Anyone didn't get?
Copper.
It's copper. It's not copper. Write the complete name. It's the salt of copper. You're correct. What is the name of that salt?
Sir, copper sulfate.
Yeah, it is copper sulfate. Okay. So what is this phenomena known as? Is
The
there any
water of
specific?
Sir,
crystallization.
crystallization.
Yeah, crystallization, or you can say hydration. Crystallize. Name the compound whose one formula unit is associated with 10 water molecules. Compound whose one formula unit is associated with 10 water molecules.
Sir, isn't it
Yes,
gypsum?
which is the formula? Which is the compound?
Sir, what is it gypsum?
No, the compound is associated with 10 molecules of water. It's washing soda, sodium carbonate, decahydrate, Na2CO3.10H2O. Okay. Anything? Next one. Next one. How is it prepared? So how do you prepare washing soda?
Sir, NS sodium chloride plus water.
Sodium chloride plus water. No. See, there were four things which you used for their preparation. I recall the four things which you used for their preparation. Yes. Anything? Done it? See, the four things which you used here, it was ammonia. I hope you are able to recall. Ammonia. Then you use carbon dioxide. Anything else? Did we use NaCl?
Yes, sir.
NaCl, then one more product. Was it water?
Yes, sir.
So what all did we get here?
Ammonia, carbon
Yes.
dioxide, sodium chloride, and water.
So we get ammonia, chloride.
It's ammonium chloride, NH4Cl, plus what else do you obtain? NaHCO3. So here you are able to get NaHCO3, and this NaHCO3, when further heated, it gives us Na2CO3.
Hello, sir.
Yes.
That's it.
So this you got Na2CO3, and the next step is crystallization. So after this you obtain, by the crystallization process, you obtain washing soda. So I think now you can do it. Name the products formed in each case when hydrochloric acid reacts with caustic soda. So what will be the product form when hydrochloric acid reacts with caustic soda?
NaCl plus H2, sir.
Okay, NaCl plus H2O. Okay, that's correct. And granulated zinc react with caustic soda. Zinc with caustic soda. So caustic soda is NaOH. Add on the reaction, that is NaOH plus zinc. So what will be the product?
ZNOH plus Na.
No. Zinc can't displace sodium. Here you have the formation of sodium zincate. Na2ZNO2. Sodium zincate is formed. Carbon dioxide is passed into lime water.
Okay, sir.
What is formed when carbon dioxide is passed through lime water?
Sir, CaCO3 plus H2
CaCO3
plus H2.
not CaCO3. Calcium carbon dioxide is CO2. Lime water is CaOH water. So of the products are CaCO3 plus H2O. Now this one, compounds like alcohol and glucose also contain hydrogen but are not categorized as acids. So discuss an activity to prove it. Yes, why? Why we have compounds like alcohols, glucose, they also contain hydrogen, but are not categorized as acids. Why? See, the alcohols,
They
like
do not liberate H plus ions.
they do not ionize. Alcohols and glucose, both of them, they do not ionize in place in water. Okay. So glucose also does not ionize. It is able to dissolve in water, but due to the formation of hydrogen bonds. That's it. Okay. Okay, so by all of you, we have discussed this almost a complete paper. A few of the questions are remaining, so this you try to complete at your home. As an assignment, you can do the remaining questions. All right.
Bye,
Okay,
sir.
bye all
Thank you,
of
sir.
you, and thank you
sir.
for your concentration. All of you remain concentrated and solve it. Bye.